Okay, this is our math project. The team is conformed by Ana Karen Puentes and Sebastián Lamas. Our problem is number 6, fx is equal to x cubic minus 3x. The first thing we have to get is restriction. However, this is a polynomial function, so there is no restriction because it can take any value, and the domain is x equals to all real numbers. For point B, that is x and y intercept, for x intercept first, we have to equalize y to 0. So we have to solve, and then we have 2 x's. For x and for y intercept, we have to equalize x to 0. This gives us the y is equal to 0. 0,0. For symmetry, we have to apply we thought that the odd formula was the possible for this problem. So it says that prove it on our equation.
To answer the point D and E, we have to find the horizontal asymptote and the vertical asymptote of the function. Do not have a vertical asymptote because it's a polynomial function. Nor a horizontal asymptote. So in order to prove that, we use the limit approaching x to minus infinite and to infinite. So we substitute the values, and at the end we obtain that
when x is approaching to minus infinite, the answer is minus infinite, and when x is approaching to infinite, is infinite. So
the limit doesn't exceed x. So in point F, we find the derivative. We apply the power rule, and we obtain that the first derivative is 3x squared minus 3. In point G, ask you to do the ID test. So we equal the function to 0, and
we isolate x, and we obtain two values. And x1 is equals to minus 1, and x2 is equals to 1. So we do the chart when minus infinite to minus 1, minus 1 to 1, and 1 to infinite. So we have to select one point in between these points and substitute in the first derivative. So first we choose minus 5, and we obtain the result that is 72. So this is a positive number. So in this point, the line will go upwards. In the second chart, we select 0, so the result is minus 3. This result is negative, and this point go downwards. And finally, we select 4, and the result is 45, so this point goes upward. In order to obtain the maximum and minimum point, we substitute these two values. We substitute the values in the original function. So the maximum point is minus 1,2, and the minimum point is 1, minus 2.
Okay, the point H is to find the second derivative of x, and we get that the second derivative of x is 6x. Then we have to do in the point I, concavity test. The first step is equalizing the equation to 0, and we get a result of 0. Then we have to apply the real concavity test, that is the same that we did on the ID test. And first of all, we get a negative result, so it's going downward. And the another sector of the graph is positive, so we get upward direction. And the inflection point, we substitute this value into the original function, and we get an inflection point of 0,0.